Hello everyone, my name is Shen Liu. I just make up this series of tutorial videos to show you how to build a basic dynamics model using ANSYS and run some typical analysis, including modal analysis, which gives you the natural frequencies and mode shapes. This will be covered in this video, and the next video will talk about for the same model, the same geometry, how to run a harmonic response to give you the forced vibration response. And the third one will talk about the transient structural model that gives you the transient response. Okay, so let's start. So when you open Workbench, you get into this empty workspace. On your left-hand side is your toolbox that has all the functionalities of ANSYS. So you can just simply drag one of them into your workspace and use that module to run your simulations. In our case, the first question is asking natural frequencies and mode shapes. So this is particularly modal analysis. So we just drag that in, and you have the modal analysis. Once you have that, as you can see, there's a list of items that you want to do, several checkboxes. So you just want to check them one by one to get your model running. So the first thing is engineering data, and that's a definition of the materials. So we already have structural steel, so that's the basic, that's a default material to be used, and we can leave it as is. If you want a different material, so there is a very complete library of all the materials that you can use, for example, aluminum alloy or other materials that you can use in the list. Alternatively, you can create a new material or just add it from a given material. For example, if I add aluminum alloy in, and I can edit the material properties just by changing the numbers here. Okay. So once you got material set, you got one tick, and you have to define your geometry. Okay, so in our model, the geometry is basically 4 beams, and it makes up like a door frame sort of shape, and you got it fixed in these 2 points. So we're just going to define this geometry. Right, so just right click and go into space claim. So this is the module or the app that ANSYS has to define the geometry. So you just have to get into that. Alternatively, you can define your geometry in another package and import into ANSYS. So that's also fine. Okay, now we get into this space claim. So this is a quite basic but easy to use package to draw a geometry. So firstly, we're looking at XY plane. So this one is built in XY plane. So we just have to define our draw plane is XY plane. Don't draw a rectangle, just draw lines. So go. The first line is 7 meters. So the unit is in millimeter. And then the horizontal line, just 5 meters. And another section is 2 meters. And then the combat has 7 meters. So that's our geometry. So because this is now it's just some lines, so we have to define them as beams. So in this case we want to do I-beams, and so we want to define two different I-beams for the horizontal and vertical. Okay, so now we can edit. So the first I-beam, which is for the horizontal, I just want to make it slightly different. Don't want to spend too much time on that. You can do it in your own time. 150. So just make that slightly bigger and shorter. Okay, so this will be our top beam, and the other one I'll just leave default as our lower beam. Okay, so the next step is to assign a beam to the lines. Okay, remember we defined some lines, but we want to assign them. So we just select the beam that we want, beam 1, and select create. So just make these two top beams as beam 1, and I select beam 2, and we'll just make these side beams. So now we have altogether four beams, and they are in different cross sections. So you can show the beam by going to display and show solid beams. So now you can see the beams. So it looks like they are not oriented to the right way. So we want the top beam to be rotated by 90 degrees and the lower beams being rotated by 90 degrees as well. So to fix that, we can go to sketch and select. So beam 1, the beam ones. So we want rotate by 90 degrees. So now see the top beam is now rotated, and the lower beam we want to rotate by 90 degrees as well. The beam that I'm using is symmetric, so the top and bottom is the same. But if they're not symmetric, you probably want to rotate 90 degrees and negative 90 degrees for those two to make them look symmetric. Okay. The next step is to link those beams, because at the moment those beams are independent, they're just moving by its own. So you just have to join them together. So the way is to select all of the beams and move to a new component. So now all the beams belongs to one component, and so you have to set the share topology into share mode. So that way we'll get a nice beam model being set, and that's done for the geometry. Now we're going to the next step is to define the model. So just double click the model. Okay, now we loaded our geometry, so let's have a look. So this is the geometry that we just defined. So you can see those lines. To display the beam structure, we just need to show the cross section. So that just shows the beam structures. So the different color represented the different types of beams. Okay. So and then we just need to do the mesh. So for our case, we just use a default mesh. That shouldn't be a big problem. So you can see we have roughly 20 elements on each beam. And this modal analysis solves for natural frequencies and mode shapes, so you have to define your boundary conditions. In our case, we got fixed at two ends, so we just fix here and here, and select multiple points. Apply. Okay, so we got fixed at both ends. Then it's pretty all set. Now we just need to add the mode shape, or in this case it's total deformation as the mode shape. And we want to set up the maximum modes to find. In our case, I'll probably do 20 modes. And we can solve for it. Okay, now it's finished. So we just need to check the result. So this is the mode shape that we want. And you can see that. So you want to see the beam. So it looks like that. And you might also want to show the result in a bit larger scale. So you can double the scaling factor. So now you can see a bit more clear. The first mode is actually an out of plane mode, so the beam is doing this motion here, about X. Okay, so, and the second mode, you just need to click and retrieve this result, and this is your second mode. Second mode is like a twisting mode. And if you want a third mode, you can have a look as well. As you can see, this becomes an in-plane mode, and the door frame is doing something like that. Okay, so, and we can do that as long as we want. As I mentioned, in ANSYS or in most of the software package, so it doesn't know what type of vibration this is. So they'll just put all the results into one big table, and it's up to you to look at the mode shapes to identify what type of mode is this vibration. Okay, so this is the frequencies in Hertz, and this is the mode shape. So that's the first part of the video. So it's just using modal analysis to give you mode shapes and natural frequencies. In this case, 3.43 is our natural frequency for this particular mode. Okay, thank you very much. I'll see you in the next video.